Thank you. Thank you for having me here. Thanks to the Hawaiian Cannabis Expo. And I'd like to give a shout out to my beautiful wife. It's our anniversary today. And she, thank you. She just presented over on the other side in the medical, on a bunch of medical stuff. So let's get started here. So I've been working with extractions and infusions for the past 6 years, and we have been testing every batch. We do several batches a week at least, whether it's an infused or extracted oil. And I am struck with we've been researching all of the different methodologies to try to come up with the best way for the best method of extraction. And so in looking at all this, I came up with there's a lot of similarities with all the different methodologies of CO2 extraction, hydrocarbon, butane, hexane extractions, ethanol extractions, and just regular infused oil. And what we're trying to do is we're trying to extract the juice or the oil inside of the trichome. And a trichome is like, if you guys, anybody, I'm sure everybody's familiar with the cannabis plant by now. There are little hairs growing on the outside of the cannabis plant that are called trichomes. And these trichomes are little factories. They make all of the cannabinoids and they make all of the terpenes inside of this little trichome. It's a fabulous little mechanism. And the rest of the plant's kind of like incidental, you know. It'll help give it a few qualities of taste and looks and smell. But the medicine involved is contained in this little mechanism called a trichome. All of the methodologies involved with resin extraction use a solvent, at least to remove the wax, if we're going to go ahead and get it all the way down to just the juice inside the trichome. All the methods involve loading the plant matter and then doing your thing to the plant matter and then removing the plant matter and filtering the plant matter from whatever external solvent you use to isolate the extract. And if we're lucky, it's going to come out what looks like in that teaspoon there. And these are pictures of trichomes. So inside of this trichome, we have, let me see. I thought these were really cool pictures of trichomes, especially this first one. And there's 3 different types of trichomes. You can see here the mushroom head trichome, then there's what I call the hair trichome, and there's another one that lays down flat and they're mostly on the leaves, and those are called sessile trichomes. The most medicine is found inside of the mushroom head trichomes. The formation of the cannabinoids inside of this little factory that we have here are formed from a mother compound called CBG, cannabigerol. All the other cannabinoids are formed out of that by mixing with an enzyme inside of the trichome factory and converts the CBG to THC or to THCV or to CBD or whatever the plant is genetically predisposed to make based on its genetics. And so it's the formation of these groups of terpenes and cannabinoids inside of this plant that give the plant its actual characteristics of what kind of effect we're going to have from the plant. And that effect can be psychological or it can be physiological. For example, myrcene is one of my favorite terpenes, and it'll give the THC cannabinoid inside of the trichome. When it combines together and is consumed either from smoking or ingesting, it's going to create like a somnolent, or it's going to make you tired. It's kind of a sedative action. That's going to be the psychological effect. Physiologically, the myrcene helps the THC break the blood-brain barrier and will help it bind with the CB1 receptor a little more readily, making it more bioavailable. So the reason for these formation of these trichomes are to attract the male pollen and the female plant by the way, these trichomes are predominant on the male plant, the female plant, I'm sorry. And so they're made to attract male pollen from the male plants. They're also there to repel pests. And like I had mentioned before, the reason is for various medical and psychoactive variations in the plant. So I'm going to give it a quick example here, and then we'll have to move on. My wife's very sensitive to different types of different strains. So it's very difficult for her to find a strain that she likes, and we found a strain called sherbet. And the two primary terpenes in sherbet are limonene and limonene and myrcene, And myrcene is usually found in more of the sleepy strains, and limonene is usually found in more of the awake strains or daytime strains or cultivars. And so it was a perfect mix for her, and because it's not too sleepy, and she can use it during the daytime, and she doesn't get jittery on it like she does with a strain that has something that would have like an upper, like alpha pinene or beta pinene. So we have different variations of the numbers of cannabinoids, over 100 in the Handbook of Cannabis 2014, and terpene numbers are over 100 based on the same source. So outside the trichome, like we said, and I thought these pictures were really fabulous. I really haven't seen a strain like this one on the right here, but I don't know if people are using food coloring or not, but it was one of the prettiest flowers I could find. But on the outside of the plant, we can see in the first plant here on the left, the moonwreck strain shows, you could really see clearly the trichomes on the outside of that plant. And the rest of that plant matter is basically cellulose and wax and some chlorophyll and other types of plant matter. So when we're doing extractions, what we're doing is we're trying to get into this trichome and get the residue or the oil out of that, inside of that trichome. And the rest of the plant matter is kind of inconsequential for extraction purposes. Now, it's been our mission, we've started to study the research, and it's been our mission to extract everything that is in that trichome, all of that oil out, based on the research that we've studied for all the cannabinoids and the terpenes based on their different entourage effect of the combination of like THC and myrcene. And I'm not going to go through all of this stuff, but you guys have seen a lot of these charts. THC and CBD are both good for pain and sleep. THC and CBD are both good for gastrointestinal disorders, and then on and on. And and then the main thing that we've found that is a problem with most extraction methodologies is that the cannabinoids are fairly easy to get out. They're fairly stable molecules. But these terpenes, when we're doing extractions, a lot of these terpenes are monoterpenes like alpha and beta pinene, linalool, myrcene, limonene. They're lighter molecules, and they have a tendency to burn off quick, or they're easily evaporated off of the plant matter. So it's especially if you're decarboxylating the medicine. And decarboxylating means that we're taking the THCA molecule or CBDA molecule or an acid form of a cannabinoid and dropping off the acid off of it and just going from THCA to THC. And THCA, because of the fact that THCA does not engage the endocannabinoid system. It doesn't activate CB1 or CB2 receptor. THC does, though. THC mimics our body's own cannabinoid called, an endocannabinoids called anandamide and 2-AG and other arachidonyl glycerides. So when we throw the terpenes in with the proper cannabinoids, we're going to be able to start affecting how a patient feels. We're going to be able to start affecting how the medicine works in the patient. And so our mission has been from day one is to get all of that out of the plant, all of the terpenes out of the plant and all of the cannabinoids out of the plant. based on our original test on the flower of the plant. And so let's say we get a 10% or 20% flower, which is fairly average, that has a 0.5% to a 1.5% terpene load, which is also average. When we increase the and with a concentrate, we're going to increase the concentration of the cannabinoid. We're getting fairly consistent and increasing it by magnitude of 4 times. So we're going to go from 20% flower, and we're going to extract the juice out of that trichome, and that's going to increase the concentration of the THC in that concentrate by 4 times, or we're going to get it up to around 80%. The terpenes, on the other hand, are going to be really hard to get them to come up 4 times. Most extraction methodologies, as we'll see here, are going to be fall far short of that, and for reasons that we'll go into. So why whole plant versus single molecule? And I think it's just, we picked this sample because it's kind of self-explanatory. I don't know how many of you know there's a product on the market, pharmaceutical product called renewal. It's an isolate compound that is made to mimic THC. It's basically the same molecule. And we've had there's no recreational use for this. There's no record of drug abuse of this. There's no record of abuse of this drug. It's a difficult drug to use, and there are a lot of reported side effects. On the other hand, cannabis is the second most popular drug on the planet, and it's illegal everywhere, most places still, to some degree. And so what's the difference between Marinol, which is actually like legal THC, and the THC we get in a flower? It's because of the terpenes and the other cannabinoids creating an entourage effect that actually makes this drug that makes you feel the raw THC all by itself is kind of a jittery, not that pleasant of a high, to combining it with an entourage effect with these cannabinoids, other cannabinoids and terpenes, and we're going to get the second most popular recreational drug on the planet, and it also is turning out to be one of the most effective medical drugs on the planet as well. So current extraction methodologies are supercritical fluid extraction, CO2 extractions, accelerated solvent extractions, ultrasound-assisted extractions. Now, accelerated solvent extractions, by that I mean that could be either hydrocarbon, butane, hexane, or ethanol. Ultrasound-assisted extractions, microwave-assisted extractions, hyperbaric plant extractions, which we're kind of hippie, and SOX helix extractions and infusions. Now, I'm going to start with SOX helix extractions because that's kind of like in the 1800s, a gentleman discovered that they could take a cylinder and fill it up with plant matter and then run a solvent over that and come up with an extracted oil and an extract. And so that was like the first methodology. That's how old all of these methods are. And so all of the other methodologies are just kind of a variation of this old method. So we'll start off with CO2. The pros are it's fast, it's easy, and there's no primary flammable solvent. The cons are we must use ethanol to finish it off or finish removing the wax. It hydrolyzes the product. Now, I'm not going to pretend to be a master chemist here, but from what I understand, if there's any water at all left in the plant matter, that it will hydrolyze, break the molecules apart, and put them back together. Consequently, when we've used in our collective, when we've had to replace, we've run out of ethanol oil and we've had to replace with CO2 oil, and inevitably we get complaints that it does not work as well. It's not as strong. So we originally thought that was because of the excess wax that's left over, but that gets washed out now, and it's still not as effective. So that we are now coming to believe that it is because of the fact that the molecules are actually taken apart and kind of put back together. They don't all go back together, so it's just not as effective. And it has the smallest yield out of the other extraction methodologies.